So this video refers to Lecture 9, Centroids, Centres of Gravity, etc., and refers specifically to centres of gravity or mass or centroid location of a composite body. Very, very similar idea to before. So a composite body, a body that's made up of several shapes. Whereas before we were looking at one particular shape, so I think we had a strange cloud, and we were saying, well, we'll break it into small sections and find the centre of each section and add them together. In a composite body, for instance, the cross-section of a T-bar, or maybe we're looking at the volume of a larger three-dimensional shape, all we're doing is breaking it into its sections, finding the centre of each section, and then working out how the centre of the whole shape relates to the centre of each section. If you actually look on slide 24, there are some very simple rules for how you would do this, which we'll talk through now. So the easiest way to talk through this, rather than just talking through the rules, is to look at the example. So if we look at the example beginning on slide 25, so this has 4 sections. There is a section that looks something like that. There's a rectangle with a quarter circle cut out. There's a triangle. And these are sections A, B, C, and the whole is an absence of section, but it's section D, effectively. So if we consider each section or segment, and we're going to want to find its area, and we're going to want to find its X position, its own individual centre of mass, and its Y position. And I've said centre of mass, I do apologise, I meant centroid, because that's what's asked for. And then, similar to the previous exercises, we've been finding X tilde A and Y tilde A. So we're going to find the central position of each of these shapes, and then we're going to work out how they all relate together. The one thing I haven't marked on here is my axes, which actually run like that, with Y and X. So the origin is in the middle of D. I've also got some radii here of 1 metre and 3 metres. So if we consider section A to start with, the rectangle, forgetting the quarter circle cut out of it. I've also missed all of my dimensions off there, apologies. So we've got 6 metres, 3 metres, that's everything, isn't it? Yeah. So for section A, I've got 6 metres along the bottom. I've got a height here, which is the radius of C, 3 metres, so 6 times 3, 18. The X coordinate is going to be halfway along A, so 3 metres. It's going to be halfway up, so 1.5 metres. And if I multiply 18 and 3, I get 54. And if I multiply my Y tilde and my A, 1.5 times 18, I get 27. That was a simple one. The triangle, a little bit more complex. So B, the area of a triangle, base times height, 3 times 3, 9, over 2, 4.5. The X coordinate is going to be 1/3 of the distance from the big end, so 1 metre in, because it's a 3 metre triangle, but the whole X coordinate is going to be plus your 6 metres for section A. So it's going to be 1 metre in section B plus the 6 of A. The Y coordinate is going to be 1/3 from the big end, so it's just going to be 1. X tilde times A, 7 times 4.5, 31.5. Y tilde times A, 4.5. Your quarter circle and your semicircle for C and for D can be found that the equations relating to them can be found on the website or through Blackboard. They'll be in the exam as well, as I've discussed previously. But the area for the quarter circle will end up as being 9 pi over 4. Similarly, the area for the semicircle will be pi over 2. However, it's a hole, it's an absence of material, so it's a negative area. The x tilde position for C will be, following through with the equation from the sheet or the website that you may have found that's labelled Centroids, with minus 4 times 3 over 3 pi. Minus, because it's back behind the x-axis, it's a negative x value. The x tilde position for D, well, the middle of D is bang on the origin, so it's 0. The y tilde position for C will be 4/3 of 3 pi. Sorry, 4 times 3 over 3 pi. 3 being the top 3 being the radius. So similarly for D, 4 times 1 because it's a different radius over 3 pi. And if I multiply these values, x tilde A comes out at -9 and y tilde A at 9 for C, and for D we get 0 and we get -2. Sorry, -2/3. So then what we need to do is we need to total up some of these columns. Just as before, we know that x bar is going to be the integral. Well, it's no longer the integral because we're looking at several areas together, so it's just the sum of x tilde A over the sum of A. So we need to total this column, sigma A. We need sigma xa, so x tilde A, the total of this column, and the total of this column, just by adding up the various values. This is where this minus on the D area comes in, because it's a hole. You have to put the minus there so that you're removing that mass later on. So when I total those up, my total for area is 28. My total x tilde A column is 76.5, and my total y tilde A is 39.83. So my x coordinate is going to be 76.5 over 28, and that equals 2.73 metres. And my y coordinate for my centroid position is going to be 39.83 over 28, which is 1.42 metres. So that concludes the example. There is one final group problem solving question which begins on slide 29. I will sketch it, but if you pause the video and then have a go yourself. If you're not sure, I'll sketch it, I'll draw the table you need, and then give you another time to pause the video before I carry on again. So this is the final group problem solving exercise that begins on slide 29. You've also been given the density in kilonewtons per metres cubed. So the density of block A is 30 kilonewtons per metre cubed, and the density of block B is 80 kilonewtons per metre cubed. And just to point out to you that this bit here is block B, so this side here is block B, all the way along the back here is all block B. So block A is only at the front. Okay. The first thing you're going to want to do, probably, is work out the weights. So you should have had a go at this already. I'm going to draw the table if you had no idea where to start. You're looking for a centre of gravity, so you're going to need to use weight instead of just geometries, but the principles are no different. You're using a weight instead of an area. So you're going to have a weight, you're going to have x tilde, y tilde, z tilde, because it's three-dimensional, X tilde W, Y tilde W, Z tilde W. A, B, and we can maybe get the total in this time because it's not too big. And just to point out to you that your weight is going to equal, well, for both of them it's going to be your density times by your volume. But for your volume for A, you're going to need to factor in that it's a triangular prism, so you're going to need to put a half in there. So the weight for A is going to be 30, your density, times 0.6 times 0.6 times 0.2 times a half, so 1.08. And your density, so your weight for point B is going to be 0.6 times 0.6 times 0.2 times 80, and that's 5.76. So now you've got those. I'll give you a minute to fill in the table. If you pause the video, come back to it when you're ready for me to go through it. So what you should have found, well, the easiest bit to fill in to start with is to add up 1.08 and 5.76 to get 6.84. Well, then your X tilde position, if we just work with shape A, well, the X direction is this direction along here that I'm marking in green. So to this corner, which I've just put a blob on, a green blob, that's 0.8 metres from the X direction. On shape A, that's this line here that's 0.6 metres. It's a triangle, so the centroid position will be 0.2 metres, or 1/3 from the fat end, so 0.2 metres there. But we're already 0.2 metres from the x-axis, or along the x-axis. So the total X tilde position is going to be 0.4 metres. In the Y position, slightly easier. I'm probably going to run out of colours here, but my Y position, that's my Y in blue there. It's halfway along that, so it's 0.1. And the Z position, well, the height of Z, again, just marked it, added that blue line there. It's 0.6 metres high. It goes 1/3 of the way up because the bigger end's at the bottom, so 1/3 of the way up will be 0.2. If I then multiply my X tilde by W, my Y tilde by W, and my Z tilde by W, I get 0.432, 0.108, and 0.216. My X tilde, Y tilde, and Z tilde positions for the cuboid. Slightly easier because I'm just going halfway in each direction. So in the X direction, 0.1. In the Y direction, 0.3. And in the Z direction, 0.3. And multiplying those through, I get 0.576, 1.728, and 1.728. And then I want to total. Well, I don't need totals for these 3 columns, I want the last 3 columns. If I total those up, I get 1.008, 1.836, and 1.944. And that leads us into the final section. So those 4 numbers on the bottom row you're going to want to carry across to the next slide if you're making notes. So my X bar position, the X coordinate of my centre of gravity, is going to be the sum of X tilde W over the sum of the weight, which was 1.008 over 6.84, so 0.147 metres. My Y bar position is going to be 1.836 over 6.84, which is 0.268 metres. My Z bar position is going to be 1.944 over 6.84 metres, which is 0.284 metres. And if we go back and look at our shape, what we're saying is 0.147 in the X direction. So let me find a colour I haven't used. I'm afraid it's yellow. So 0.147 in the X direction. It's going to be somewhere. It's going to be somewhere within this block. If you can see where that yellow line's just been added. Well, that kind of makes sense because most of the weight's at that end. I'll take that off. 0.268 metres in the Y direction. Well, in the Y direction, we've got, it's going to be almost in the middle here, but not quite, slightly closer to the A end of the shape. Well, that makes sense because most of the weight's at the A end of the shape. And in the Z direction, 0.284 metres up, so it's going to be that sort of height. Well, that kind of makes sense because the A is fattest at the bottom, and that's the bit that's going to add weight to our B, so yeah, that kind of makes sense too. So we've done a quick logic check there to make sure it all adds up. That concludes the group problem solving exercise. It also concludes the lecture 9 on centroids and centres of gravity.